Sorry, sir.
Good morning. I welcome for this 26th webinar by Indian Concrete Institute Bangalore Center in association with Bangalore Institute of Technology. We have today an eminent speaker, Anjaneyappa, Associate Professor, RV College of Engineering, who is an expert on bituminous road constructions. So even though we are a concrete promoting association, Indian Concrete Institute, but concrete can sit on a very solid foundation. It may be road construction or a building. We need to have a completely stabilized soil or stabilized road to do any construction. So in this scenario, so today we are having an eminent speaker speaking on salient aspects in bituminous road construction. Continuously, Indian Concrete Institute Bangalore Center, in association with various engineering colleges, promoting many innovative technologies, many innovative products for the benefit of the professionals. So today we have this privilege of introducing a new subject through Concrete Institute. It's on salient aspects of bituminous road constructions. So today over to Dr. Ashwath MU, principal of BIT, to take over and address the gathering and speak about a few words about Bangalore Institute of Technology and ICI. After that, I think Dr. H.B. Balakrishna sir will do the welcome. Over to Dr. Ashwath sir.
Okay, thank you, Dr. Manjunath. I welcome all the participants for this very interesting topic. From last few days, I was getting some calls from the people that a lot of topics on concrete, please organize some different topics. So I'm very happy today we have a slightly different topic other than concrete. And as Manjunath mentioned, we not only promote concrete and concrete related activities, but all other activities and best practices that we follow in the construction industry. And I'm sure all the participants today will get benefited out of this topic, salient aspects in bituminous road construction. I thank Dr. Anjaneyappa for accepting to be the speaker for today's program, and Dr. Balakrishna, Professor Head of Civil Department, BIT, and Professor S. Purnachandra Tejasvi, who's in charge of this program. They have taken efforts in coordinating with Indian Concrete Institute for organizing this event. And I'm very happy, and I would like to recall that Bangalore Institute of Technology, we always used to associate with professional bodies and organize programs at our Dr. S. Ramegowda Seminar Hall. And I was missing that evening lectures at our seminar hall. And thanks to various organizations like ICI and ACCE, through these webinars also we can connect each other and organize the programs. So these joint programs and collaborative programs will definitely continue and add value to the participants. So at this point of time, I would also like to indicate all the construction professionals that ICI is a large body present across the country. And I was the immediate past president of Indian Concrete Institute. We have been organizing a lot of knowledge dissemination programs, and the membership strength of ICI is more than 13,000 in the country, and a lot of programs. And our president, Mr. Vinay Gupta, is also doing a lot of activities on ICI. So from ICI, greetings to all of you. And I'm also part of Bangalore Institute of Technology, and we always support collaborative programs with any professional body. And I appeal to all the participants, if you would like to utilize the facilities at BIT, we have an excellent library. We have both our reference books and digital library also. We have the VTO consortium, a lot of journals are also available, and we welcome all of you to visit our library facilities and make use of the facilities. Once again, from BIT and ICI, I wish all of you a very happy and safe time because of this COVID-19 pandemic. We should be very careful in mitigating this pandemic and come out of this situation. I'm sure so far we have managed this crisis very well, and now all the restrictions have been removed. And I appeal all of you, please take extra precautions and see that you will be safe and come back to the construction industry without any problem. So with this few opening remarks, I welcome once again and over to Dr. Balakrishna.
Thank you, sir. Good morning, everybody present in the webinar. I am very happy to welcome Dr. Manjunath Yellar, Chairman of ICI Bangalore Center for this webinar. Welcome you, sir.
Thank you, sir. Thank you.
I welcome Dr. M.U. Ashwath, Principal, Bangalore Institute of Technology, also the President of Association of Consulting Civil Engineers, India, and the past immediate President of Indian Concrete Institute, Bangalore Center. Welcome you, sir. I welcome Dr. Anjaneyappa, Associate Professor, RV College of Engineering, who is the speaker for the day on the topic Salient Aspects in Bituminous Road Construction. I will hearty welcome to Dr. Anjaneyappa, sir.
Thank you, sir. Thank you very much.
I welcome Purnachandra Tejasvi, who is the faculty coordinator for the current webinar. Welcome to Purnachandra.
Thank you, sir.
I also welcome Dr. R.L. Ramesh, who is the Secretary of Indian Concrete Institute, Bangalore Center, for the webinar, and all the office bearers, Pasha, and all the office bearers of Indian Concrete Institute for the webinar. I also welcome the student participants, my colleagues, my friends, and all the participants present in the webinar. The topic is very interesting, and stay with us till the end of the webinar. If you have questions, you can post your questions in the quick Q&A section. And end of the webinar, there will be a Google form, and first 100 participants will receive the certificate. Since we have the limitation, every day 100 certificates will be sent to you. So all the 500 plus participants will get the certificate. So once again, welcoming all the people present in the webinar, I request Purnachandra Tejasvi to introduce the today's speaker, Dr. Anjaneyappa.
Good morning, everyone. It is my privilege to introduce today's webinar speaker, Dr. Anjaneyappa, sir. Dr. Anjaneyappa completed his bachelor's degree from RVCE, PG degree in highway engineering, and PhD from UECE, Bangalore. Dr. Anjaneyappa started his career in industry as transportation and highway engineer and has worked in organizations which include Sundaram Consultants, Transportation Engineering Research Foundation, Dalal Consultants and Engineers Private Limited, and Ingersoll Rand India Private Limited. Dr. Anjaneyappa has served as assistant professor and associate professor at RASA Center for Road Technology and is presently working as associate professor Civil Department RVCE, Bangalore, and is actively involved in various consultancy works and research projects. Dr. Anjaneyappa has been involved in organizing training programs for engineers of government organizations like PWD, BBMP, KIADB, and other private organizations. Dr. Anjaneyappa has been involved in industrial consultancy, which includes preparation of DPR, pavement failure investigation studies, and involved in industry-sponsored research projects by ACC Cements Limited and Ingersoll India Private Limited. Dr. Anjaneyappa is member of various professional organizations, which include ASCE, ICI, IGS, Institute of Engineers. Finally, Dr. Anjaneyappa is credit close to 20 publications in reputed and peer-reviewed journals. Thank you. Over to our HOD, Balakrishna, sir.
Thank you, Purnachandra. Now I request Dr. Anjaneyappa, sir, to the stage is yours. Please address the gatherings.
Thank you, sir. Thank you, one and all. Once again, good morning to one and all. Hope I am audible. The topic of today's discussion is the salient aspects in road construction. Of course, that includes, as Ashwath sir, Balakrishna sir said, it also includes concrete road construction and little more focus on bituminous road construction. If we take a payment cycle, road payment cycle, life cycle,
we have 4 stages, important 4 stages. Number 1, we characterized, we survey the materials, we screen the materials, we approve the materials which are meant for road construction. It's a very important task. If we take a road construction, the cost component of road construction, 50% of the road cost goes to materials. That means 100 crores road project, 50 crores we spent on the materials. So much is the importance for the materials, and definitely the surveying of materials, checking the suitability of these materials, and approving this and utilizing these materials in for the design and construction is a huge step towards the sustainability, what we talk, towards the optimization of the cost is very important step. That is the first and the very important cycle. The second stage in the payment cycle is the optimization of these ingredients, the materials, and the design aspects, and finally coming out with the optimal design based on the life cycle cost analysis, or based on the cost, based on the financial constraints, doing the best design, coming out with the best design is very important step. Let's say we have good materials, the best materials, and if we do not optimize these materials and the cost, then there is no point having these important resource. So design also plays a very important role as far as cost and life of the structure is concerned, or the performance of the payment structure is concerned. Then comes the third stage, the production stage. We have characterized the ingredients, we have come out with the best design, and implementing this design or putting this design into practice is very important. Not only important, it's a complex process. This production process is very complex and very important. We have materials, we have good materials, we have very good design. Unless it is put into practice, then everything, these materials, this design goes in waste. So this is what the topic of today's discussion, which will be interacting more on this important phase. And then comes the fourth stage in the payment, that is, of course, we have produced a product, and whatever the product that we have produced, this payment product, it has to serve its intended purpose. It has to satisfy its customer. So this product, whatever we manufacture with the materials, with the best design, end of the day, it has to serve its intended purpose. That is, it has to satisfy our road users or the customers. So performance or the maintenance is the last stage. As I said, most of my discussion interaction today I am focusing on the construction, and as I said, many discussion points what I coordinate today is also holds good for concrete road construction also. So if we take this production process, especially this road production process, construction is unlike, we have different production process and production environment. Let's take a factory. Let's take a Volvo factory. They also produce the products, many products like pavers, the rollers, excavators, and so on. There, the production process is highly controlled condition. The production process is highly controlled, and the minutes are counted from one bay to another bay. The raw material enters the first bay, and the final bay comes out with the product, roller or the paver, and in each bay, the process is measured in minutes. God sake, seconds are not counted. So everything is highly controlled. And if something goes wrong in a particular bay for a few minutes, you'll get the buzzer and you'll get the assistance. And if again it is not controlled, something is not happened properly, then your floor manager will rush to you within no time. If again, then your senior manager, your general manager, whole setup will be there in the highly controlled environment if something goes wrong. Take our production environment. Let's the civil engineering production environment. We have different building infrastructure, road infrastructure, and so all this production environment. What is this? If you look at this setup, it's a temporary. Take the BIT. It is there for the last more than 60-70 years. That structure, education production structure, and it will be there for centuries to come. And there is everything is meticulous. 9 o'clock class starts, first period ends at 10, the second faculty goes there, the CIE timetable, final attempt, everything meticulously runs, and there is no hiccups. Even if there is the problems, the complexity, if they find any, suddenly there will be the professors, there will be HODs, there will be the principal, and so on. Everything will come into picture. The setup is permanent. When I say setup, the production setup is permanent. We will be having everything to take control of the production process, this construction process. But look at our civil engineering construction. It is not permanent. It is a temporary structure. Our construction structure is temporary. What does it mean, temporary? It depends on the life of the construction period. It starts from, let's say, 3 months to 3 years or 4 years or 5 years. So we start with zero resources, men, material, machinery, etc. We start with, in this production process, we start with zero inventory, zero resources, and we end with zero inventory. So today there is nothing. We mobilize everything, the money, material, machinery, everything, and see after 3 years you find nothing, including man. Nobody will be there. So it's a temporary structure and mobilized for short duration, and once the mission is over, it ceases to exist. So this is an important aspect of civil engineering road construction. Now let us look at the road construction environment within the civil engineering construction environment. Unlike a building infrastructure site where maybe the construction site is 5 acres or 10 acres, where we have the project management setup there, the GM sits there, the DGM sits there, the manager sits there, the workforce quarters will be there, the site engineers will be there, everything is set up, the workshop, the concrete plant, the material stockyard, everything will be in the place. And there it is fairly controlled. If something goes wrong, you have the manager to support, you have the DGMs to support, you have the project manager to support. Yes, you have the laborers to help, because they'll be stationed there only in the quarters. So there it is better controlled. Look at this road construction environment. The places are spread out. If you take a 50-kilometer road project, your camp office will be 30 kilometers away. Your project manager sits there and you work 30 kilometers away. It is not controlled. We are exposed to rain, we are exposed to dust, sun, etc. But if you need some help, you have to wait. And you know that the time is the essence of any contract or construction. We cannot wait in the construction. But fortunately, road construction environment, the area is spread. Many times we are forced to wait for the signal from our superiors. Many times. Why we do that? Because any small mistake we make in the road construction, the financial implications are so huge. You may be aware that we don't talk in lakhs in road construction. We don't talk. You may not even find the 1 crore project, 2 crore project most of the time. Road construction project, all major projects runs into 100,000 crores, and even the small road project, the smallest road project, the PMGSR project, runs into 2-3 crores. So any small mistake during the execution, any mistake due to the decision we make involves huge financial risk, and this is the reason many times we are scared to take decisions. We wait for the green signal. We wait for the approval. So what is the implication? Time is the essence of contract. The cost shoots up. The setup becomes ideal. So it's one of the important risk that many road engineers, the construction industry face. And the third important the aspect of road construction is we have 100 kilometers road, and we would have prepared the detailed project report based on some sample test. Let's say generally we take the sampling soil sample at every 1 kilometer, one sample, and we presume that entire 1 kilometer is represented by the properties whatever we determine from that one sample, one specimen we take in each 1 kilometer. Many times, and this DPR is also prepared, as you know, it's investing crores of rupees. The crores DPR cost somewhere it's around 3%. Let's say if it's a 500 crores project, the cost of preparation of the project reports runs into crores. The fees, consultancy fees. So much care is taken, but in spite of that, when we actually start the execution in the construction, maybe my CBR at chain age 1.1 is, let's say, as per the DPR, yes, I have truly taken this sample, I have tested it, my CBR comes to 5, but 5 or 6, whatever it is, then based on that, the design would have designed the payment, and as a constructor, that is what I am executing in the site. I have mobilized everything to the site and just doing my work, and suddenly I found that the soil at that particular chain it is not as per my DPR. DPR says it is 5, and now it is, let's say, 2. So it is so much implication. I cannot continue with my execution because the difference between 2 and 5 makes lot of financial implications. So I am forced to stop my execution in spite of mobilizing my resources to the site. So these things do happen because we cannot test the entire population. Let's say 100 kilometer DPR I'm preparing. It is humanly impossible. So representative samples every 1 kilometer. In between 1 kilometer, the strata may change, the properties may change. So these are the environment, and we stay in remote areas. Maybe I am working in Bangalore. So I get anything. I want a good food. I want a good evening recreation. Yes, I can have. But I stay in the remote area. If something is required, yes, it is difficult. So this is the typical environment we work. So this all influences the construction, whether it is concrete road construction or the asphalt road construction. The other important, as far as when we talk about road construction is the balancing the production. In the road construction, the chain of equipments comes into picture, starting from the crushers, then production plant, whether it is hot mix plants or concrete plant, and then the transportation equipment, then comes the paving equipment, then comes the compaction equipment. There's a chain of equipment in the production supply chain in the equipment spread. If something goes wrong in between, the whole chain becomes standstill. Let's say I have produced the hot mix, very costly, as you know, very costly. I can afford to lose. I have produced the mix in the hot mix plant. I have transported. This happens for the concrete. I have produced the concrete mix there. I have transported to this site, and suddenly my paver is not working. Surprises can happen. What is the implication? The whole my chain comes to standstill, right? My production setup becomes standstill. And what is the financial implication? So the one load costs several lakhs. I cannot use that. I cannot throw that. So that is the situation. So the balancing the production in the supply chain, in the equipment side, is very important and very difficult. Many times it goes out of our control. So especially because we work in the rough situation in the remote areas, this is an important aspect to be looked into. When we look at this typical cross section of the pavement, whether it is a concrete road or an asphalt road, these are the layers, bottom layers that we found. There is an embankment constructed to maintain the vertical profile. We need to run the pavement, construct the pavement to the required vertical profile. So to maintain that, we always construct embankment, or we may go for cutting. And above that, we construct the foundation called the prepared subgrade, 500 mm for major highways, 300 mm for minor roads, village roads. Above that, we construct a GSB layer, Granular Subase layer. Mainly, it's a structural layer again. Apart from its structural function or load-bearing function, the another most important function why it is constructed is to drain the water from the entire pavement system. And then above this GSB, we construct the granular base layer, especially in our country. Wet mix is the commonly used base layer, a load bearing structure. This is a gap graded layer. We'll have more white so that permeability will be easy. And this is wet mix macadam, is a dense layer, well graded mix, so that it takes up the high stresses, wheel load stresses, and also with a very high modulus. Above this, we may construct a DLC layer if it is a concrete pavement, and above that we may go for a paving quality concrete layer. If it is a flexible pavement, we go for a bituminous layer. Now let us take this the bottom layer, embankment or subgrade, a subgrade layer, a typical subgrade layer. How looks like the compacted subgrade layer. And if you look at the MRTH specification, these are the requirements says. For the embankment, the laboratory density requirement is, minimum requirement is 17.5 kilonewton per cubic meter. Approximately it's a 1.75 gram per cc. The minimum density, this is the material requirement, not the compaction requirement. Any material that we use in subgrades, that soil should yield when we test in the laboratory, modified Proctor density should give so much value, 1.75 gram per cc. Only that soil is qualified for use in shoulders, verges, backfills, or the subgrades. Suppose if it is an embankment subjected to long periods of inundation, water, then not embankments exceeding 3 meter height, subjected to long periods of inundation, then we can use this soil which can yield a density of 1 gram per cc. If it is subjected to extensive, if the subgrade or the embankment is subjected to extensive flooding, extensive inundation, then the soils should yield in the laboratory 1.52 gram per cc. What does it mean? Anything which gives less than this density in the lab are not qualified for use in construction. And the minimum density for the subgrade is 97% field density. For the subgrade, 95% for the embankment. That means whatever the minimum field density to be achieved is 97% for subgrade, 95% for embankment. We have to remember that whatever the specification says, that is the minimum specified. Most of the times we check the field density. If it is 97% for subgrade, then we stop rolling. Why? Because yes, we are sure that the density achieved meets the requirement, MRTH requirement. No, what is specified is minimum to be achieved. looking at the equipments we have today, the modern rolling equipments, we can achieve even 100%. 100%. What is the implication? Let's say I have the same soil, let's say soil having CBR5, both soils I have used in the subgrade and now compacted. Now I have achieved 97%. I pass that and go for next layer. The same soil I have achieved now 100%. What is the additional effort I am putting? I am putting additional passes, additional more roller passes. That's all I am doing. So what is the implication? My density increases from 1.75 to 1.78, let's say, or 97% to 100% or 99%. 2% increment I get. What is the advantage I get? You know that the whole payment design, the two important inputs for our payment design is the CBR, the second one is the traffic. So the whole design, the layer thickness depends on these two important parameters. Now, just by rolling alone, same soil, just by rolling alone, putting additional few more passes, if I can increase the density from 95 to 99%, it is highly possible, I may increase my CBR from 5 to 6 or even more. Advantage is I can reduce the layer thickness. What is the advantage? Consequence, I can save the extraction of huge quantity of materials. You may be aware for just for 4-laning one project for one package, let's say 50 to 70 kilometers. We use millions of lakhs of cubic meters of soil and aggregates. Just if we save just a few mm's of the layer thickness, we save huge quantity of materials. What is the effort we are giving? Putting additional few more passes, not just stopping at 97%. So so with increase in the density, the increase in CBR is very, very evident, and this should be made use of. So when we are doing constructing soil layers, constructing embankment or the subgrade, whether for concrete road or for the bituminous road, the most important, there are n number of quality parameters if you look at the specification. But what is more important is whenever we go for soil layers construction, we have to maintain uniform lift thickness. Let's say the maximum allowable thickness now is 250 mm. Let's say loose thickness can be 300. So that 300 should be uniform even for the first layer also. We cannot put 300 mm or 250 mm one place, 270 another place, and 300 one place. So this is very important. Why? We get uniform density. It is not only achieving the minimum specified in the MOTS specification 97. It is also important, equally important is achieving uniform density. That is one of the intention why we prepare this subgrade. We want the uniform strong bed for the payment layers, irrespective of concrete or the bituminous layers. That is one intention. If the density is not uniform for this foundation layer, subgrade layer, then the behavior will be different. And that leads to different performances. So if the thickness is not maintained uniform, we do not get uniform density. This is one of the common labs that we do even today, not only in the small projects, even in the major projects. So we especially with the initial layer, the thickness, if you look at the first layer, at one place you will have 150 mm, one place you have 300 mm, right? So this optimization is required. Nothing we lose. Maybe we may use the grader for another 30-40 minutes, or maybe we may use an additional 2-3 labors, and that's all the resource I waste. But this, if we achieve this uniform thickness and uniform density, the performance improves and justifies the investment we make on the road infrastructure. The other important aspects whenever we are constructing soil layer is, yes, earlier it was 200 mm, now the maximum lift thickness, layer thickness, allowed compacted layer thickness is 200. Now it is 250 made in this revision, 250 mm. And many times, especially, we may go little beyond this. Not in all projects. Few projects I have seen, they put little more than this, thinking that yes, this vibratory layer compacts. We should not take this risk. We should not take this risk. It should be limited to the maximum of 250 mm. Why? Because this is a foundation layer. If something goes wrong in the top layers, in the bituminous layer, it can be easily patched, and somehow, yes, even after getting the bangings, it can be patched overnight. It can be done easily. If something goes wrong in the foundation layer, embankment or the subgrade, poor quality construction, then we have to do the whole surgery. We have to reconstruct. We have to remove the whole layers and reconstruct, or we should leave it to God for few years, because it's a trait by itself. Nature is such a beautiful agent. Everything it tries, it stabilizes, but that takes time, 3 years, 4 years, etc. So what we are doing is compaction, not doing consolidation. So we should not make any mistakes, especially in the foundation layers. Any mistakes, the financial implications are more. I am not telling we can make mistakes in the top layers. No, at least the financial implications are more, the risk involvement is more. And as we all know, the OMC and the density curve lowers, the compaction should be carried out at the OMC. OMC, but many times it so happens, and for the soil layers, the truck comes, it sprinkles the water, and tomorrow morning we comes and we compact. The OMC and the density are so sensitive to each other. OMC plays a vital role. If OMC is not there, then we may not achieve the maximum density, and that results all these implications and complications, whatever we discussed so far. So maintaining OMC is very, very important, so that we achieve the maximum density possible, so that we can optimize the materials, we can optimize the design, and we can even get the better performance. So this is again a lapse in our construction. We sprinkle water, but we don't mix it. Some places water content will be at OMC, some places it's at below OMC, some places at more than OMC. So we don't get uniform density, uniform performance of the layer. So that is one. And the next thing is, whenever we are constructing the soil layers, is the water comes. Somebody may ask, we need let's say per lane per kilometer, we need 1 lakh liters for maintain for soil layers or the entire road construction. Where do we bring this water? Fortunately, today is environmental day also. Sustainability is very, very, very important in all the aspects, in all the construction aspects that we carry out. So 1 lakh liters per lane per kilometer is a huge quantity when there is no water in the water scarcity area. And using so much water is again a big question, and there are no simple answer for this. One time, on one side we talk about the density, which is dependent on OMC, on the other side this is the huge quantity of water. Today, if there is any precious water, a precious material on this earth, construction material, that is water. So one via media solution, not a optimal solution, ideal solution, via media solution is put more compactive effort if the OMC is less in the soil layer. See, higher compaction effort, more number of passes can compensate this lower OMC in the soil layers. Then comes the granular layers. After talking the soil layers, again this granular layer is a sub-base layer. GSB layer is common both for asphalt pavement as well as the concrete pavement, a very important layer. Apart from load bearing role, the main function is the drainability, removal of water from the pavement system. As we know, the number one enemy, number two enemy, number three enemy for road failure is water. If we take control of water, whether it is concrete pavement or the bituminous pavement, it will serve its intended life. So what is this I'm trying to present here is grade 1, grade 2, grade 3, grade 4, grade 5, and grade 6. And the intention of GSB is gap graded so that water flows easily, voids are more kept. Within this GSB, if you see the permeability based on the research carried out by Professor Kavita Frasta, you can see the variation in the permeability. For grade 1, it is 668 meters per day, and for grade 6 it is 1300, and for one grade it is about the highest is for grade 3 5000 meters per day. This is at a hydraulic gradient of 0.025. If you increase the gradient, we will have different gradients, chambers, cross slopes. So if the gradient is more, if the cross slope is more, then see the permeability, it increases. We need more camber, of course, difficult, but we should know that more is the cross slope, more is the permeability, and the minimum, at least minimum, the specification, some specification says it should be more than 300-400 meters per day. Yes, if the further slope is increased, then your permeability decreases. What is more important for a GSB layer, granular subbase layer, is controlling the finer content, controlling the dust, controlling the passing 75 micron in the layer, granular subbase layer. As we know, the intended purpose of the GSB is to drain out the water, so that to keep the layer system intact, stable, safe. So if you increase the percentage passing 75 micron, varied from 0.5 to 3%, here 4%, see how the permeability decreases. When there is no fines, the permeability is around 5500 meters per day, and when this finer content increase to 1%, from 5000 the permeability comes down to 2000. That is the influence of the permeability in the GSB, the influence of the finer content, 75 micron content in the GSB mix. So we need to take, suppose if the finer content is increased to 4%, many times it does happen in majority of the constructions, the finer content will be somewhere here. I have not seen the zero fine content, and practically it may not be possible, but what is the important target for in the GSB is to avoid the 75 micron. If it is 4%, see, from 5500 to 1000 it has come down. So much is the performance reduction, and we know what will happen if the permeability reduces. The whole system fails. Whatever the best resources, the best design, the best management practiced during production process, construction process, all will go waste if this layer do not have. We have investigated, we have seen many major road projects have failed in the initial stages just because of the poor material composition in the GSB. So this is very important. So if we take care of density in the subgrade layer, majority of the problems get solved. Any soil layer, embankment or subgrade, density we have to focus. In the GSB layer, we have to focus on the 75 micron control, how to control the dust and how to control the gradation, because gradation plays a very important role in the permeable. So gradation and the dust control is important. Then comes our wet mix macadam or any granular layer, including GSB. This layer I'm talking about. The commonly used granular layer is wet mix macadam. We know that the granular layer strength comes from aggregate interlocking. So for that to happen, If there is no better interlocking, the strength will not be there. If strength is not there, the pavement may fail, or pavement life may come down, performance becomes poor. So whenever we are constructing any aggregate layer, like crusher and macadam, wet mix macadam, or even GSB, so interlocking we should ensure. That is the reason why we have to maintain the specified gradation and the shape also. The other requirement is lateral in confinement. You can see these are all, you can even in this picture you can see we have constructed wet mix macadam layer, we have constructed GSB layer, but either side you are not seeing the confinement. What is that? If there is some disturbance in the edges, the whole locking, whatever that is achieved by rolling, it will go waste, and the whole layer collapses. It becomes unstable. In spite of using such a precious material from the mother earth, the purpose will go waste. So giving confinement, maybe by constructing the shoulders, good shoulders, is an important requirement whenever we expect. This happens even today, starting from small projects to major projects. You can see in all, we don't give importance for the lateral confinement. This should be there. Many times it so happens that we construct the binder layer, DBM layer. Of course, it's a dense mix, very strong layer, stable layer. Many times for some reasons, practical reasons, we delay the surface course, BC layer. Till then, what happens? The traffic moves on, including the construction traffic. God's sake, if it is a rainy season, yes, it's a dense mix DBM, but water infiltrates, it loosens the layer becomes less stable and leads to failure. So as far as possible, when we construct this DBM layer, binder layer, even the BM layer, it should be covered with a surface layer at the earliest as possible, at the earliest, so that we can safeguard the life. Many times it so happens we construct this wet mix layer today. For some reasons, there is a delay in constructions, we may not construct the bituminous layer over that. After some time we construct, we may go for DLC or GSB, or we may go for a dense dense bituminous macadam. In between 15 days, 20 days would have elapsed. Some moving traffic would have disturbed the top layer. What we do generally, in the name of preparation of this layer, when we go for next construction, we again compact. So compacting already compacted layer, it destabilizes. The interlocking goes. So not to be done. Only, especially vibratory pass, I have seen people doing vibratory pass before constructing the DLC or before constructing the DBM over wet mix macadam. Not to be carried out. Only sprinkling of water and static passes are to be done. Static roller passes, not vibratory passes. And the important aspect in the road construction, in the pavement layer construction, whether it is GSB, wet mix macadam, or is control of segregation. I'll come to that little later. So then comes the bituminous layers after discussion of soil layers and granular layers. Now let us look at some important aspects of bituminous layers. Many times we overheat the bitumen, because many times the quality control engineers, when the mix is delivered at the site, the first important thing that we do is we check the temperature in the site before rolling, before paving. It's a very important property, because it's a viscoelastic material. So because of this reason, many times in the mix plant we overheat the mix. That is one. Second, equipments are all operated by the skilled operators. Many times it so happens, human error, we overheat, so that kills the life. The age reduces drastically if we overheat the bitumen or we overheat the bituminous mix. That is one. Second thing is, if the lead is more, if the distance of transportation of this bituminous mix is more from the plant side to the construction site, just to maintain the paving and compaction temperature, we heat the mix for longer duration in the plant. That is also very, very dangerous. It kills the mix. It kills the mix. And then comes gradation is very, very important. As said, density for soil, gradation for aggregates. For bituminous layers, it is temperature and gradation. Temperature and gradation is very, very important for the bituminous layers. And the other important aspect is paving. What is this paving? Paving, whether it is slip-form paving, concrete paving, or asphalt paving, paving is an art. Paving, more than engineering, it's an art. And when we say paving, it's a continuous process. There should not be stop and go. Whether it is concrete paving, PQC paving, or asphalt bituminous paving, the moment we stop the paving, we get a weak plane, we get a weak spot. So ideally speaking, once we start the paver, we should not stop it. Then only we get uniform quality, good product, good quality product, good performance and everything. The moment we stop, we are creating a weak plane. So what is that? The paving speed, the mix required for the paver, the lead distance, the transportation from the plant to the site, all are to be coordinated well, whether it is concrete paving or asphalt paving. The plant capacity, RNC plant capacity or HMP plant capacity, the lead distance and the paving speed are to be meticulously planned so that the paver do not stop for any reason, very reason. And when it comes to the compaction of asphalt layer, bituminous layer, especially we should not put high vibration for the thin layers less than 20 mm, 25 mm. Vibratory compaction not to be carried out, very dangerous. And then there is no point in compacting the asphalt layer when the temperature is less. Another important aspect many times we do in the gradation maintenance, I was telling, gradation is very, very important. I've seen many, my friends in the field. So these are the typical gradations for DBM, BC, and this is how it comes for all the pavement layers. So what the gradation means, there is a particular size, let's say 26.5, 90 to 100%, 1971.71 to 95%, 13.2, 56 to 80%. Let's say like that it goes. So let's say 37.5 mmC, 26.5 mmC, my percentage passing is 90, let's say, and I take 19 mm next sieve. Now my percentage passing is 95. So here also it fulfills, here also it fulfills. Now take 13.2, my percentage passing is 56%, then also it holds good. No, that is not the gradation. Though it is a range, upper limit and lower limit are given, we have to follow a particular trend. It's not that 90 here, 95, 56, 54. That is not gradation. Though it fulfills, meets, falls within the band. No, you have to follow lower limit or upper limit or middle limit. Middle is ideal. So that is what the gradation mean. And this, look at this. This is the tolerance. You can see in this slide what is the importance given for the gradation. If I do after construction, if we go and check, do the postmortem, take out the material and see, this is the tolerance. The gradation should not deviate from 1.5 to 8%. It is very, very difficult to maintain the gradation because we work in the highly uncontrolled, adverse, rough conditions. But again, it is very, very important to maintain this tolerance within this. Why gradation is so important and why it is difficult to maintain? We have all types of problems. We have mainly the segregations. We can have mechanical segregation. That's where the bigger stones separate from the smaller ones. We have temperature segregation because of the variation in the temperature of the mix. Some places we have different size aggregates, other places we have different. So these are the two types of segregation we face. When we look at the segregation, we say gradation is very, very important for asphalt layers or granular layers. But look here, this is the hopper bins of the plant, and directly tipper comes here and unloads here. Part of this mix goes here also. and we would have adjusted these openings based on the job mix formula. But if we do unloading carefully, then this material goes to this cabin and this material goes to this here, and whatever the design, all our job mix formula, whatever we have done to maintain the gradation, it will go waste. That's one. And this segregation can happen like that, and the feeder bins are not full, empty, and pug meal we don't mix for most of the time, and not loaded properly, or we use ineffective blades, twisted blades, worn out plates, right? And the segregation can happen due to the loading pattern. So this is how the mix to be loaded in the tipper. The first load should be dumped here, the tipper should move, and the second load should be dumped here, and the third load in between, so that to certain extent the separation of bigger particles from the smaller ones is minimized. Then comes the segregation during transport. Because of the movement of the vehicle, the bigger particles rolls down, and many times these small batches should not be carried in the large truck. Whenever we are, the mix should be full in the truck. With the small batch we are taking, then we have to use small batch. There's no point, I mean, it should not be, we should not take the small mix in the large truck for any small quantities, this thing. And no point of time in the paver mix should be less, at least not less than one third. So during segregation it can happen, and during paver, see, this is the typical scene what we find in majority of the road construction, not in major road construction project. Majority of the road construction side, this we see the paver hopper is emptied, and you will wait for load to come, and now this material mix is unloaded, and once this load loaded, this truck goes and it finishes this. So this situation, this kind of situation creates lot of segregation, non-uniformity, quality product, poor quality product. This should never be done. I was also telling paver never to be stopped, whether it is concrete paver, in this case it is bituminous paver, ideally speaking, unless it is very, very essential. So that is one care we need to take. No mix should be there in the hopper, right? This is another view. And always the tipper should not touch the paver. The tipper should come, stay away at least 1 foot away from the paver, and paver moves, touches the paver. This is a careful operation. By any chance, if this touches the paver and you get a bump, you will not get a smooth surface, right? And then comes the paver. The speed is to be maintained, vibrations are to be maintained in the paver. Many times people don't put vibrations, and I have seen many times I mean, heating of the screed is another important. Many times people keep operating this paver, especially when inspection authorities goes to the site, suddenly they increase the lift thickness, layer thickness, and sometimes they decrease. There should be minimum people. Too many cooks spoil the food, especially during paving of asphalt layer. There should be minimum the skilled people in the site, and the paver should not be touched quite often unless is very, very necessary. So if we change any the angle of attack, what we call, if you increase the thickness or decrease the thickness of the layer, it will not happen immediately. It will not happen immediately. At least it takes 10 to 12 meters, 12 meters in a sensor paver, about 15 to 20 meters in a mechanical paver. By the time whatever the desired thickness you get, that will take 20 meters. That you find after 20 meters or 10 meters. It will not happen immediately. That means if we keep rotating that screw, then we will not get uniform surface, uniform undulated surface we get. And as you know, the very important, one of the most important function of the surface there, concrete or the asphalt layer, is to have a smooth riding surface. And if we do keep changing this auger changing this agar, then we will not result in the good product. So change of the screed, the height not to be done. And the head of materials before the screed, paver screed, also should be maintained. This is applicable for all, even in the pug mill, whether it is concrete mix plant or the wet mix plant or even the front of the auger. Always the mix, ideally speaking, the volume of the quantity of mix in the pug mill should be to the half of the blades or half of the paddle, so that the mixing will be uniform. And by any chance, if it is overloaded, mixing will not be uniform. Any mix, whether it is asphalt mix or concrete mix, if it is less, again it will not result in a good mix. So maintaining a uniform head of mix in front of the paver is very, very important. If the head is low, you get a thin layer. If the head is very high, the thickness increases. Let's say if the more material is drawn and put before the screed, here up till here the layer was uniform, and suddenly the thickness rises, resulting in non-uniform thickness. And again, by any chance, if the material is very less, head of volume of material in front of the auger is less, see up till here it was coming normal, and suddenly the head of material in front of the auger reduces and the screed decreases, settles, screed decreases, settles, and layer thickness become and small, and the layer will not be as per our requirement. So maintaining uniform head in front of the auger of the paver is very, very important. Not only in front of the auger, any mixing plant, any pug mill, the head, uniform head, and half of the head is always ideal. And this is the pictures of a typical construction site, normal construction site. You can see here the trucks are standing waiting for unloading the mix onto the paver. I was telling, keeping the mix for longer duration is also not good. It kills the life. And look here, there is this joint is also not straight, not uniform. In this side, you can see it should be something like this. So this improper joint, always any joint for that matter, whether concrete pavement or asphalt pavement, is a weak plane. The first distress appear in the joints always. If you ask me, the first distress in the normal case, always you observe it occurs in the joints. It occurs where you have stopped your paver. It occurs where you have started your paver. Always the first distress. So this is not a joint, and this can be maintained. It's not that it cannot be maintained. Our laborers are so skilled, this can be maintained meticulously, and this looks so simple. Maintaining a joint enhances the life drastically. And this is what the speed to be maintained depending upon what is our hot mix plant capacity. A typical curve from the taken from the famous equipment manufacturing company Volvo. So this is the capacity of the HMP, hot mix plant, and this is what the paver speed, the spreader speed we have to maintain depending upon the what plant we have, and what is the thickness of layer we are constructing. These are the typical layer thickness that we adopt in our country. Generally 75, 50 are very common, 40, 50 and 75. And we adopt generally 100 to 200. Very rarely we go for 250. So depending upon the hot mix plant capacity, depending upon the layer thickness and the width that we pave, this speed need to be maintained. This helps in continuous paving. So then comes compaction. Very, very important aspects. Increases the stability, reduces the deformation. It decreases the cracking potential, reduces the moisture penetration. Of course, we have different types of rollers in use, widely used. All these type of rollers are used everywhere. And of course, this is for the soil compactor. the asphalt compactor. Only difference is for soil and aggregate compactor, we have one steel drum. If there are two steel drums, so this is asphalt compactors. If there are pneumatic wheels, then it's called pneumatic rollers. Now, this pneumatic roller plays an important role because this simulates the field condition. This is used at the intermediate rolling level. So because of the tires we use, pneumatic tires, it simulates. You might have observed immediately after the construction, the texture looks very open and rough. You go after 1 month or 2 months, once it is open to traffic, you find a smooth face because of the movement of the traffic would have sealed, made the texture smooth. To simulate that, we use this pneumatic roller. Not only that, the advantage of using this pneumatic roller is this is articulated wheel. It will touch all the surface. It follows the profile of the bottom layer, whereas the other rollers are rigid. Here. It will not touch. So this pneumatic roller touches all spots and compacts, seal the surface. So that's the advantage of pneumatic roller. What is more important here is many times for maintenance activities, in the especially pothole patching or in the backfill areas or near bridges, culvert construction sites, our bigger equipments, compacting equipment, do not go because it is 2 meters wide and 5-6 meters long. And that is the reason most of the times when we cross a culvert, we get a jerk dump. So we can automatically tell this is a bridge site or a culvert site, or even backfill you find settlement. Why that? Because we do not use appropriate compacting equipment. So on these type of compacting equipment, whether it's a compactor or a handheld rollers, are very important for compacting the backfill. So that's very important. Of course, in some of the projects people are wisely using and they're using it, but majority of the projects I have seen reluctance in using these small equipments, and of course they are quite affordable compared to the cost of big roller, 20 lakhs. This is very less. It can be afforded. So the construction of joints is also very important when it comes to the sequence. Staggering of joints, the transverse joint, top layer and the bottom layer. Bottom layer I have constructed DBM, top layer, let's say BC I am constructing. The transverse joint, I should know where the DBM transverse joint is. I have to stagger the bottom, the BC layer joint at least by 2 meters. And even the offset of 150 mm should be given for any longitudinal joint. Bottom layer, I should know where the longitudinal joint. When I am paving the top layer, I should have the offset of at least this 150 mm. Otherwise, it will be a big, as such, joint is a weak plane. And if the joint, bottom joint, longitudinal joint, and top longitudinal joint comes in the same place, then it's vulnerable to the failure. And overlapping, generally people follow 25 to 50 mm. So this is the sequence we follow: breakdown rolling, intermediate rolling, finish rolling. And what is important here is the first roller pass on the bituminous mix is very important, because that is where it is something like we take it can be molded to any shape. Mix will be in the very hot condition. If we make any first mistake in the roller pass by giving jerks or by bad maneuvering, the mix will mold to that shape and difficult to bring back to the next shape. And even if you bring back, the life goes down drastically. The first roller pass is very important. And another important thing is we should have a mean rolling zone. At least it's a big roller, we should have some front at least 50 meters to operate. Otherwise there is no point in rolling. So maintaining rolling zone, at least some length for roller to operate behind the paver is very important. Many times it so happens you don't find roller, paver goes there, the roller goes there, comes back, and rolling zone is not maintained. All these are very, very important. So uniform speed during the rolling. We should not allow the roller to stand on the surface, no jerky start, no sudden braking, no sudden maneuvering. We should not use water for wetting the surface, roller wheel surface. We should use detergent or a vegetable oil. Then we should know that the majority of the compaction is done by paver itself, 75% approximately. The remaining 20% is done by the roller. So roller does the tamping it does, and all the compaction up to 75% it does, and remaining 20% is only done by the roller. So paving and compacting is very, very important. Many people, they don't switch on the vibratory in the paver. That's very, very important. Then comes this picture shows one of the embankment site. This is the high embankment, about 8-9 meters or even more, and you can see here a new stream has formed here. New stream, it was not there earlier. This was the original road, and new flow you can see here. And this is again, I'm showing the picture. Huge quantity of soil materials, huge quantity of aggregates materials, another picture, and huge quantity of asphalt or concrete layers. This thickness 200 to 300 many times. What is those figures tell us? Believe me, if there is a hillock like this, you have a package of 100 kilometers, 6-lane project. By the time we finish this 100 kilometer 6-lane project, you will not see this hillock on the Mother Earth. Major portion of this hillock will vanish from the Mother Earth. I'm not at all exaggerating. And you know that we have 60 lakh cubic meters of road network, the second highest in the world. Second highest in the world. And you may also know, so far we have covered only about 50%, and 50% yet to rehabilitate. We should bring it to the good road condition, right? And what is the quantum of material we are using in the road construction? About 10 lakh cubic meters, 10 lakh cubic meters for every 100 kilometers of 4-laning. 2000 cubic meter per lane per kilometer of new construction. 175 lakh cubic meter per kilometer per lane for every 5 years. 170 per, this is for maintenance. Every 4 years, 5 years, 6 years we do overlay, thin layer. For that we need so much cubic meters, and approximately we need about 2 crore cubic meter for every 5 years for the road network, huge road network we have. You take only this 10 lakh cubic meter for every 100 kilometer 4-laning. We have about 1 lakh kilometers of national highways alone. 50% of that warrants 4-laning. And see this another statistics, 20 lakh cubic meter of soil for every 100 kilometers. Imagine one tipper carries 20 cubic meter, normal tipper. Medium tipper carries 20 cubic meter. Imagine how many tipper loads for 20 lakh cubic meters, and how many kilometers of roads we have. It is not one time going. Every 5 years we need to maintain, or at least every 20 years, 30 years we need to maintain. So there are big challenges the industry is facing. And look at this crushing plant, dust aggregate crushing plant, and see this hot mix plant. Of course this is little exaggerated, but I want to convey here huge smoke we are emitting to the Mother Earth. Look at this slide, the consumption of the fuel. We use lot of equipments. The consumption varies from Normal consumption for the big plants varies from 10 to 60 liters per hour. We run in 2 shifts, 3 shifts. So this is the approximate diesel fuel calculation per lane per kilometer. We need, if it's a new construction, we need 10,000 liters per liters per lane per kilometer. Imagine how much fuel we use in the road construction. So what are the challenges? Of course, the good material sources are depleting. Because we need good materials, fortunately South India we have good materials. North India we may have to go 50-60 kilometers to get even good soil for your construction. So high transportation costs, and we cannot use many natural resources and materials. Strict regulations are there. What is this? We are extracting lakhs and lakhs, and we are vanishing the hillocks, hills from the Mother Earth. Huge erosion, sedimentation. We are creating new streams, new cross, new ditches, new ponds. These are the realities. Whether we like it or not, we should accept it. So we have been talking about the sustainable technologies, new technologies. Fortunately, today is Environment Day, and this is a good food for the thought. What is the solution? Should we stop our construction? Not possible. Should we stop maintaining our roads? Not possible. Then what to do? There are no simple answers. Some creative or what you call out of box solutions are required for the road industry if we want to stop this degradation. If you ask me what is the answer, I don't have the answers. I don't see. So something should come up. Otherwise, we don't know where we are heading. We need both. We need good roads, and at the same time, we need to save the materials. But no concrete solution has come so far. Here and there. The other important aspect the road industry is facing today, road industry, entire road construction industry, concrete or asphalt, irrespective. Our labor is like a cook. Labor is a cook. You give all the good materials, good rice, good masala. If labor is not in the good mode, you may put little more kara, little more salt. All the materials, the good materials you brought from good mall goes waste. The same way, it's a good materials, good design, good construction manager, world-class equipments. End of the day, it's all these are handled by our skilled man, labor. If he is not in the good mode, many times he will not. You can many the road. See, the skilled labor come to the road industry, what we call the tar industry, as a last resort. If you get a good monsoon in his native place, he goes back. He never comes to this industry. So, because this is the last option, because not. So all this good design, end of the day, good materials, everything is handled by this skilled man. We engineers, we simply go there, we guide them, we tell them, but handling is all done by this. This man is very, very important. If we want good roads, the first and foremost importance should go for this labor, this skilled man. Unfortunately, we are not attracting the laborers and retaining these people in the road industry for various reasons. Their welfare is not well taken care, even in the big projects. Forget about small projects. And we train them, but the expertness, the skillness goes, because once he gets good train, gets a better opportunity, he leaves this industry and goes. This retention is not there. So this something the entire industry is responsible, the client, the consultants, the contractors, everybody responsible for this lapse. So unless this man is well taken care, we cannot see good roads. More than engineers, he is an important man. And you can see the share of the skilled laborers. Of course, this is 2016 statistics. 84 to 95% is the man required for the road industry. So very, 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 very important. And construction, if you take road construction, I was telling, if you take the road cost component, 50% of the road cost, project cost, we spend on materials. 15 to 20% we spend on plants and machinery. Sorry, this is less than 10%, not 50. 10 instead of this is less than 10%. Definitely not 10. I say always tell less than 5%. Less than 5%. HR cost is less than 5%. So that means if there is a 100 crores project, 1000 crores project, we will be spending 150 to 200 crores only on the machinery. Believe me, 1000 crores is not a thing in the road construction. You may tell why I am telling 1000 crore. So this is for some students present here. So it's nothing. So much money we spend on the plants and equipments. But fortunately, if you look at the industry, we are not optimizing. We spend so many. The cheapest equipment is roller, 20 lakhs. Hot mix plant, 4, 5, 6, 10 crores, 7 crores. The pug mill, the grader, 75 lakhs. The paver, 1 crore, 2 crore, 1.5 crore, 75 lakhs, even mechanical paver. So the all equipments worth in crores, but optimization, whether it is a major project, NHA project, or a small PMJ project, in spite of investing 15 to 20%, we are not at all utilizing them. Utilization in some of my study, it indicates not even 50%. In fact, I got 30% for majority of the equipments. What is that? We are wasting lot of money on this important equipment. So end of the day, in the industry, we need a reliable road infrastructure, green infrastructure, smart infrastructure. More than that, human infrastructure, it should serve its intended purpose. So I thank the BIT. My slides are coming to end, my presentation. So my thanks are due to BIT, and I say especially Professor Purnachandra, Professor Balakrishna, Professor Ashrat, Dr. Manjunath, Dr. Ramesh, who gave me this opportunity. And above all, thank you for all your kind attention. Now open for some clarifications. Over to Purnachandra. I think I believe I am on time.
Yes, sir. Thank you very much for that wonderful presentation. You have touched upon pavement cycle, road construction, pavement layers, and the talk was very much useful in terms of material, the characteristic, handling procedure, quality aspects, and it was very informative and useful for students, practitioners, and the road constructors. Sir, it was really good, and thank you very much for that wonderful presentation. Now, Dr. R.L. Ramesh has joined us. Welcome you, sir, Dr. Ramesh.
Thank you, sir.
Yeah, we will have few questions.
Yes, sir. Yes, sir.
1 second. Sir, what is the span for the concrete road? That was the first question we received.
What is the?
Maybe lifespan they are asking, it seems.
I did not go. Come again, sir. Please. Once
what
again.
Is the span for the concrete road?
Okay, lifespan, I believe.
Yeah.
See, I think I'll consider it as the lifespan. For a bit asphalt pavements, it is 15 years, we say 10 to 15 years, 10 years, 15 years. Design life we take. For concrete roads, we take 20, 30 years. The next question suddenly somebody may pose. Have all the payments survived for 15 years? And what is this 15-year mean? I am a little bit confused there. I don't want to confuse students there. Yes, it will serve for 15 years, 10 years. And yes, the concrete payments serve for 30 years, even more. There are old payments, concrete payments constructed, served even more than that. The road in front of Vidhan Sauda was there till 15-20 years back. We used M20, M15 concrete, but the situation, loading conditions were different. But if you ask me, have you seen the performance of the concrete life or the 30 years? It is, see, its concrete mix is such a wonderful material, characterized in the classical way, better way than asphalt, where we rely on mechanistic empirical. Yes, it will serve. If you ask me Indian statistics, if he's a student, my dear friend, you have to wait. The earliest road we have constructed, probably the Delhi Mathura road, I think 85, it's almost 25-30 years old. Yes, it is wonderful. And the other roads in the first package, the Rajahmundry Thune Karnataka, we have Belgaum Maharashtra road, is almost 15 years over. Wonderful. So by default, I no doubt to believe it will serve more than 30 years. But do we need more statistics as far as performance is concerned? Yes, we need more statistics.
Okay, sir. We have one more question from Pradeep CP. Sometimes while testing field density for embankment, we get more than 100%, like 103% or 105%. What is your comment on it?
100% fine. See, this is what wherever I go, I always tell don't stop at 97%. Go ahead for higher density because we have wonderful equipments. It can definitely compact 100%. But what Mr. Pradeep is telling, 103, 104, you have to cross check the result. Is it one specimen result or look at the results. Generally with density we take 10-15 result and then see. If it is a single result, something should be wrong. I am happy with 100%, more than 100%. Please look the data.
Okay, sir. Saurabh Kumar is asking how to ensure uniform OMC, optimum moisture content.
That is what the road construction is an art. I mean, more than we engineers, that's what I was telling. It's skillness. Generally, what we do is today we spread the layer uniform thickness, and then we have to calculate what is the existing moisture content in the layer and what is the OMC remaining water content to be sprinkled. Right? We can have the controlled sprinkling. So yes, it can be very easily done. We have done. In fact, myself has done personally. Though I am an engineer, I have done. So it can be controlled. Once it is done, allow water to spread. Leaving time for water to spread is also important. Then probably you come. That's what we do in the laboratory also. Laboratory OMC compaction test. We have to add the water, then for the pulverized soil, and then we have to leave it for curing, so that water spreads the entire soil mass, and then we should mix. Here also, after water is sprinkled, then next day probably you come with the grader, mix it thoroughly. That's what, see, that is what for all the products, engineering supervision is very, very important, especially for the road construction. And for that reason only, because you are in the open, controlled, harsh conditions, you have got discretory powers. If you look at the schedule of rates, for all specifications says it should be as per IS, IRC, etc., etc. Only for the road, it says as per IS so-and-so class or MR so-and-so class, or as per the directions of the engineer in charge, that special powers are given. So we should be there, ensure uniform mixing, and check manually. Check you have the quick equipments to check. Looking at the investment, we spend 10-15 crores per kilometer. So much looking at the money, we quickly check, and that can be ensured. So uniform water content can be checked easily and can be done. Some people are doing it really, and majority of the people are not doing. And it's a simple mechanism, simple thing, so that we can optimize the material, etc., etc. I think it can be done. Sprinkle, mix grader, experienced grader operator can mix very well, because while grading, the blade can be controlled to the required depth meticulously.
Okay, thank you. And Spurti is asking how long will asphalt driveway last? How to increase its durability?
There are many things, as I said, to increase the life. I was telling in the first slide, materials, good ingredients, good design, good construction, good maintenance. All four are equally important. If any one link misses, then definitely life decreases. There are new materials. new materials are coming. What I meant in the last slide was there are breakthroughs, there are big things, the research is happening, etc. What I am seeing is whatever the practice is looking at the sustainability is not sufficient. Some out of box thinking, some critical breakthrough is required for the entire road construction industry, irrespective of asphalt, bitumen, or any concrete road. So durability can be increased. There are many ways, recycling, sustainability when it comes to the modified binders, the concrete pavements. There are some additives which has come. Many things, stabilization. So many things are there. So many things are there. All this.
Manjunath is asking, what is the advantage of white topping over bituminous roads?
Definitely, see, one of the biggest problem, I'm telling both sides, it's not the all there is asphalt roads are also good, concrete roads are also very good. So both are good. You cannot we cannot tell one is superior to other. What is happening in our urban roads, especially urban roads, we know how drainage is, right? Even a small rain, you get lot of ponding, and we know the enemy of road failures, 1, 2, 3, it's water only. So if you compare the bituminous roads and the concrete roads, definitely concrete roads sustain this problem much better than our asphalt roads. So that's why it's always concrete roads, especially for good roads, arterial roads and so on. These concrete roads are better. So white topping is one model in that concrete type. So if you look at the structural behavior of asphalt road and white topping, what we say is it's same. It's flexible behavior only. Whereas concrete PQC layer, concrete pavement, it is slab behavior. Entire load is borne by the slab only. Bottom layers only to have a good uniform support so that this compression member do not breaks. White topping behavior, flexible pavement behavior, it's same. Grain to grain contact, load distribution from top to bottom. That means all bottom layers comes into picture. But again, what is the cost is the difference? Yes, if you take the life cycle cost, both cost more or less it's maybe 10-20% it's more. Then why the blocks are reduced 1 meter by 1 meter, 1 meter. So all this to reduce your all cracking behavior, cracking behavior of the concrete mix. These small blocks are, I mean, we do that joints, 1 meter joints, 0.6 to 1 meter joints.
Okay.
Life definitely it is. Life it is a overlay. White topping is a overlay. It's a layer.
Okay. Dr. Puneet is asking, how efficient is it to use plastic in bituminous mixes?
It's an accepted practice, widely used practice. We can use and people are using, even in Bangalore, people are using. In fact, major contribution as far as plastic use in bituminous road construction is from Bangalore engineers, Bangalore University. So it's accepted, giving good performance. But only precaution to be taken is the quantum of plastic. If you look at the ARC, the quantum of plastic and the type of plastic is controlled. That is to be controlled, not to be more than 5-6% because it is more dangerous. The gases that we get is more dangerous. So that's how why the quantity is controlled.
Okay, Kshitij is asking how many samples are required to check the field dry density, and at what interval we should do the field dry density and moisture test.
There are MONTS specification for every, if my memory is correct, one density for every 2000 cubic meter, or you have to do at least a 10-15 tests and then do the statistical analysis. Okay, but as far as number of tests concerned, I don't remember. It is around one test for 200 or 2000 square meter area.
Okay,
I don't remember the frequency of testing.
Yeah. How moisture is controlled in the sites in case of dry lean concrete?
Oh, so because we work in the open air, it is difficult to control. If there's a very big, first thing is that's what the first slide I said. We weigh the fracks in the balance. Road construction is like weighing the fracks in the balance. If you look at the why the moisture is controlled, we ask for the tarpaulin, temporary shed. We ask for the temperature range. We ask for the ice in the chilling plant, the chilling plant in the concrete plant. We look for the tarpaulins for the transportation. We check the temperature dumping. So all this are to be taken care of. Maybe initial stages we can have deals, we can have more slump, but uh, uh, first few loads, later the right moisture content to be maintained. Controlling is very difficult, I believe. I agree, but it needs to be controlled. It controls everything in concrete.
Okay, there are many questions. I'll take 2 to 3 questions because I think we are running out of time. Ramesh Rao is asking how simply we can overcome the problems while constructing roads in hilly areas.
Hilly areas. Come again, sir. How to? I mean, problem of construction
How
in hilly
simply
areas.
we can overcome the problems while constructing roads in hilly areas. He is not specific about quality of material or the alignment. His
Yes, correct.
soil stabilization for road foundation maybe his question.
Yeah, not maybe. Soil stabilization is a very old engineering solution for many of the utilizing the poor soil for road subgrade or embankment, especially for subgrade and subbase layers. It is widely used, widely accepted, and but somehow in between 60s, 70s in the literature it was widely used. In between we stopped practicing it, but guidelines research is all done. In the off late, in the last 10-15 years, there are many commercial additives have come into the market who recommends the stabilization using those additives. They can be used. I have seen their results are also good, but the cost is not matching. Cost is not matching. At least I don't know about the performance cost because we have not seen the performance. That will come only after 10 years or so. But the initial cost is abnormally high, 4 or 5 times high than conventional stabilizers. That's one part. So definitely constructing roads in the hilly areas, mobilizing the equipment resources is definitely a tough task compared to plain areas. As sir said, drainage is a big issue there. Controlling the drainage is a big challenge and needs to be controlled. The landslide, geological structure there is a big issue. Of course, the controlling, if you control drainage, then everything is controlled there.
Okay. Sir Likith Kumar is asking in the road construction, clay sand is coming. What are the admixtures used?
Any clay soil, see, we can use any soil which generally which gives the density more than 1.75 gram per cc. I was telling that. But for me, if you ask me personally, the God has not created any waste material on this earth. Every material is precious and every material can be used in road construction, especially I can confidently tell in road construction. Only thing is it needs to be properly engineered. In this case, clay. Yes, clay is a predominant material in the any soil. Even Bangalore soil is a loamy soil. Here also we find clay, but the quantum is less. But there are many types how we can use clay. Number one is you can go for conventional, as Sir was telling, the stabilizers, lime, cement, etc. Or you can use industry byproducts with the clay, or you can use some commercial additives have come in the market that can be used so that the PA is reduced. The swelling character, why we are scared of using clay? Because of that swelling and shrinkage. That needs to be controlled. That is can be controlled by mechanical stabilization. Add good materials with the clay. That is one way. Add control the drainage or control the variation in the moisture content of the clay structure. That is another way. Of course, then go for stabilization. and any kind of stabilization. So we should not be scared of clay. It can be used, and we have used. It should be used. Please remember, any materials can be used. There is no waste metal. The term using waste metal is gone. No more there. All are at the most we can say marginal material, conventional material. I mean,
Okay.
alternate
And
material.
I have a question. When we visited Japan, we could not see trees on either side of the highways. When we asked, they said the trees affect the life of the road. What is your comment on this?
Yes. There are advantages, there are disadvantages. If trees are there, yes, for non-motorized traffic, it's a advantage. Who cycle, bullock carts, etc. For them, it's an advantage. For high-speed vehicles, it's a danger because they need a lateral clearance from the what we say friction. Lateral clearance. More is the speed, more is the distance to be maintained from the trees. So capacity of the road reduces. Accident prone, right? So the trees always should be away from the carriageway or the roadway part as far as safety is concerned. The advantage, as I said, for non-motorized traffic, pedestrians, it's useful. When it comes to the performance of the pavement, if it is very nearer to the shoulder, yes, it may damage. Water may get into, especially for the new pavements, water may get into the subgrade and then it may kill. But we would have taken care of this drainage water problem in the pavement by constructing GSB layer. Any water, we will not allow water to get into the subgrade by constructing GSB, whether it is from sides, whether it is from the top. So we need trees, definitely. It controls the pollution, it controls the air quality, but it should be away. In fact, it is made mandatory also. Roads, but it should be away from the frictional zone. It should be away from the carriage.
Okay.
Advantage.
Sir, we have heard smart cities, smart buildings. When we say smart roads, any equipments or digital equipments used in case of smart roads to to get the load coming on the road or the passenger car units like that, any stress or strain patches?
As far as Karnataka smart cities are concerned, I have not people have not told me about any smart equipments, smart materials utilization. It's conventional only, I believe. You are right, sir. Some performance, some smart control, all those things, intelligent ITS system into the roads is very much essential. But there is a big reluctance. We don't know. The youngsters know. We don't, because we don't know, we cannot implement. We are resisting. Maybe next generation it will be all right. It's a lapse. I do agree. But as such, I have not seen any smart road here. At least in Karnataka, I am aware. I have not seen. Other states, I am not aware.
Over to Dr. R.L. Ramesh. I think we have taken sufficient time.
Yes, sir. Yes, okay, no problem. It's a good session. I have one question. So regarding
Yes,
about the question is related to the life cycle of the payment. So either it may be a flexible payment or it may be rigid payment. I will told that the design life of a flexible payment is 15 years and the rigid payment is 30 to 40 years, or it may sometimes it may goes 50 years also. But we have seen the Bangalore metropolitan city. So we have seen every year they are laying the flexible payment. But see, once the life of that payment, even the one rainy season, it may wash away. So who will we have to blame? Whether they have maintained the quality or not maintain the quality, who is responsible for this public funds like this? So because they are spending a lot of money on this, okay, this flexible payment, not even we cannot see 5 years also. So within a one rainy season, it's completely wash away from that place. So who is responsible? How to comment on this?
So very complex question. Difficult, not just engineering question. But if you ask my personal opinion, I am also closely associated there also. I know the problems. Who is responsible? If you ask me, we are all responsible. The citizens, all stakeholders are responsible. It is outrightly we cannot tell go for concrete road, it will perform better, or go for bituminous roads, it will perform better. We cannot tell that. So compared to where the drainage is problematic, definitely concrete roads perform better than asphaltic roads. That is very clear. But who is responsible? Earlier, if you Ramesh sir, if you remember, 30 years back, there were big rains. But the TV, we never used to hear bari male, underpass near nintide, gadi hoga kaitil. We never heard that. The same rainfall has intensity or the quantity of rainfall has not increased. Only these problems have increased. We do not have proper drains, and we do not have the continuity of the drains. Number one is we do not have proper drains. We do not have the continuity of the drains. Who is responsible? We find houses, we find debris. After all, engineer is also our brother friend there, who is on the other side, we are on this side. So who is responsible? If you ask me, my honest opinion, we are all responsible. We are all responsible. Yes, quality also comes into picture, but that is not alone the reason. I'm not telling corporation is doing wonderful quality work, and I'm not telling that. But big share is also from this side, from our side. There is a share from that side also. Definitely, I cannot neglect that. I don't have a station because I'm this side also, I'm there on that side also.
Okay. Yeah.
Okay.
Thank you, sir. Sir, Balakrishna, sir.
Yeah, my father worked as an engineer in public works department in 1972-73. We used to see a lot of tar barrels stocked on the side of the road and tar plants. It was scary to see people how they work in such a situation. They used to use make use of kerosene to heat the car.
Yes, sir. Yes, sir.
Now we have mixing plants, and sea of change has occurred in highway construction. Thanks to the people who have modified the process. So I think Purnachandra is also there. Any questions from Purnachandra or discussion points?
Sir, I want to ask one question.
Yes, sir.
See,
Yeah.
all the government authorities dig up utility for utility purpose, but they are not going to fill it properly. So there is a lot of money wasted there. Again, they have to go for construction or a maintenance measure. So what is your suggestion, sir?
There is a wonderful procedure in the corporation. There is a protocol, standard operating procedure, when to cut, why to cut, when to get the permission, who should cut, what to do, what not to do. Everything is there in the system. What is lagging is we see one thing is water is more, utility cuts are more important. Maybe utilities for a water supply line, it is more important. We cannot tell don't cut because water is more important than a road. But maintaining, there is a system in place, but implementation, I don't know what to answer. There is a standard operating procedure, well placed standard operating procedure.
They have to follow it.
That's what, who should follow? Everybody. Man who is digging, man, the owner, the people, everybody. If it is my house is there, I don't care, even wait for corporation engineer. I'll bring some coolie and I'll dig myself if it is my house. So such things are also happening.
Thank you, sir.
Thank you. Thank you.
Thank you very much, sir, for that wonderful lecture and the question and answer session. We have many more questions that will be transferred to you.
Yes.
Hope you will answer them through mail. The mail IDs will also be shared with you. Thank you very much, sir, for your wonderful lecture. I thank Indian Concrete Institute, Karnataka Bangalore Center for providing the opportunity. I also thank Dr. L.R. Manjunath, who is the current chairman of Karnataka Bangalore Center. I thank Dr. R.L. Ramesh, who is supporting all the institutions and encouraging all the institutions to conduct the webinars and share the knowledge. Thank you, Dr. R.L. Ramesh. Thank you, Pasha, for providing all the support. And thanks to Bangalore Institute of Technology, Dr. M.U. Ashwath, for encouraging us to conduct the webinar. Thank you, Purnachandra, for all the support extended to us. I would like to repeat, all the participants will get Google form, try to fill the feedback, and then you will get the certificates back to your email. Thanks to all my students, colleagues, participants. Over to Dr. Anil Ramesh for the closing remarks. Ramesh sir.
Ramesh sir.
Ramesh sir, you are not audible. Hope you are muted.
Sir, voice ಕೇಳಿಸ್ತಿಲ್ಲ.
ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ.
Ramesh sir.
ಅನ್ಮ್ಯೂಟ್ ಆಗ್ಬೇಕಂತ.
ಇಲ್ಲ ಅನ್ಮ್ಯೂಟ್ ಐತೆ ಬಟ್
Parts of the construction of the payments roads. Okay, so definitely they will make use there in future. So on behalf of ICI Bangalore Center, thank you once again, sir. So I thank all the attendees, whoever participated for this today's webinar. So on behalf of ICI, once again, I thank you one and all attendees, and as well as to success this webinar supported from all the peoples who have directly or indirectly helped to conduct this webinar. Thank you one and all. I thank Purnachandra especially taken very initiation to conduct this webinar.